Today's video will talk about how to prepare alkynes and work through some sample problems, especially trick questions. But first, let's talk about how we even get to alkynes in the first place. So in the end, we get an alkyne, acetylene, but to get there, we need a proton source, which is usually an acid. And then before that, to even make the alkyne have a negative charge, we will need a strong base. And before that, we will need two leaving groups because that means we can have two hydrogens, and then this can attack this hydrogen and kick that out. And we repeat this twice, and that will get us the two pi bonds we need for this alkyne. So that's why we need two leaving groups, or we can also have one leaving group and one alkene. That will both get us an alkyne by doing this twice. But let's just say you didn't start with this. They gave you an alkene to start with. So how do you prepare an alkene into something that has another leaving group on top of it, or two leaving groups? Okay, so let's take a look. So we already have this step matched up. If we want to bring an alkene into something that is halogenated, we will need to halogenate it. So in this case, we added some chlorine 2 diatomic, and that is an alkene addition reaction. However, this is halogenation, so that's how you get two chlorides on it. And let's choose a solvent. We used this, and then that's how you get to this part. Okay, so if you did not start with this, let's say if you started with just an alkene, do not just add this to it and assume you'll get an alkyne. No, you have to halogenate it to get you two leaving groups or one leaving group and one alkene, and then you start with this important step. But then let's just say they didn't start with an alkene, they gave you an alkane with a leaving group, and you want to get to this point. So then what you have to do is you have to go through elimination E2, since it's on the terminal carbon. That means if we use a strong base, it will attack the least substituted, which means this carbon, and essentially the leaving group will go and you will get an alkene in the stead. Okay, 1 second. Okay, I added an extra line here. There we go. Yeah, so here you can use tert butoxide. And then if you'd like some heat, so that will give you E2. So for this little bit, I just wanted to let you know that we know that you make an alkyne with these two steps, but that's only if you get to start with something lucky, like two leaving groups or one leaving group plus one alkene, then you can start with this step. But if you don't start with this step, if you start with this step or this step, you gotta prepare it by eliminating it, making an alkene, and then halogenating it to get to this point. Okay, keep that in mind for the exam. This is just to exemplify that. Okay, now let's try some very specific problems. Kind of straightforward though, but it's kind of a trick question. So in this problem, this will basically just give it a negative lone pair, and with a lone pair, then we can attack this nucleophile, can attack the carbon, and the leaving group will leave. But when you redraw it, be really careful. Okay, so this was the point where it's separated. So now we know there used to be a bromine that is gone, and now there's two carbons. Okay, two carbons. So this is our carbon 1, this is our carbon 2, and then this carbon 2 is attached to our phenol. So then you see that there is this bend here. Okay, be really careful. It's easy to miss a bend, so really make it clear. Okay, and then for this next problem, this will make this negative, and then this will be a tertiary alkyl halide, which is not a good substrate for SN2 reaction. So that means we cannot just copy paste this little bit on this lone pair. What that means is we will not draw our usual products of just combining the things, but we'll have to draw an E2 and a no reaction product. So a no reaction product is straightforward. It's just gonna be, you just draw whatever you had. So we had this, no reaction. This is just what we had in the initial problem without the lone pairs. So this is answer number 1, no reaction. And the second answer to add it is, since this is tertiary, it's gonna favor elimination 2 instead of SN2 because it's way too hindered for SN2. So then for E2, you're gonna redraw this little bit, but then the leaving group is gonna actually leave. There's no more leaving group, and now you will replace the leaving group with an alkene. So that is how you do these problems. So quick debrief. In the first part, we talked about how to prepare alkynes when they don't give you what you're supposed to start with, and then how to get to that point by halogenation and elimination if needed. If you're starting with an alkane, do elimination, and then if you start with elimination, and then if you start with alkene that's already been eliminated, then you halogenate it, okay? And then the second part we talked about is be really careful when you combine two things together. Super easy to mess up, sad points to lose. And the second part is, what if your Rx, your alkyl halide, is not primary? If it's secondary or if it's tertiary, you will get an E2 and a no reaction answer. So I hope this video was helpful.